This is the first exam review video for Chapter 7. In Chapter 7, we split that into two units: exponent properties, which was all the rules that govern how the exponent functions can be worked with, and then exponent functions, where we graphed and looked at behavior that can be expressed by an exponential model. So as you're in the exam review, the first page has a lot of multiple choice. I would come back to those after you've done some of the other exam things that are on here. So for instance, coming down to the section that starts around 18, there were multiple rules that governed our exponent work that you learned and that you should get onto your note sheet. And the first one was, and we'll look over here, the first one was if I have the same bases and I'm multiplying those values together, then I keep the base and I add up the exponents. So if we look through here, we can't see one that looks directly like that, so we'll leave that rule for a minute. The second one down said that if a value already had a power on it and then a second power was being put on that, that we would keep the base and multiply the powers. And if you look through the part that's 18 through 22, there's several cases where that's what's happening. So in number 18, they've got 12x to the 5th, y to the 12th, all being raised to the second power. The first reminder we gave you was to put the powers on everybody. So 12, we always tried to put multiplication dots in between, then x to the 5th, and then there's another part of that product, that multiplied set of values, that also has its own power. So make sure everybody's power is showing. Then you could apply that power to a power rule and power everybody up by the power that's being put on them. So 12 to the first squared becomes 12 to the 1 times 2, or 12 squared. 5 to the x to the 5th to the second power becomes x to the 5 times 2. And y to the 12th squared becomes y to the 24th. And then you have that choice of making this 12 squared into a value from your calculator, a value that you know off the top of your head, with 144, x to the 10th, y to the 24th. You can see that that rule also comes into play in number 19 and again in number 22. Other rules to think about: negative exponents. If it has a negative exponent in the numerator, then remember that we move that expression to the denominator, but only the part that had the negative exponent on it. So a to the negative n really means that it belongs as a divider to the positive n in the denominator. You also saw ones where the negative exponent was in the denominator, in which case you kept the base but moved the power to positive in the numerator. And you can see that there's ones like that in number 21, there's negative powers, and in number 20, there's negative powers. And sometimes you move the negative powers, and other times you leave them where they are and apply other rules, like this final reminder rule. You had a few more on your note card, so make sure you're actually looking there and moving those over. And this would become, if I'm dividing powers with the same base, I subtract the exponents. So if I'm looking at 21, I might be able to apply both those rules. I see one part that's division and then one part that's multiplication. So on the first part that's division, I can apply the rule that would say this will become z to the 5th minus negative 5 for that first part. So that first part becomes z to the 10th. And then we still need to multiply by that z to the negative 3. We have a few ways you can do that. We could go back to the very first exponent rule, because we are multiplying now, or we could rewrite that negative exponent. I think just using that first rule and saying, okay, now I have z to the 10 minus 3, or z to the 10 plus negative 3, z to the 7th. So pause the video and spend a little more time in the 18, 19 parts and see what you can work out, making sure those exponent rules get onto your note sheet. In 23 and 24, they had you solving equations with exponential expressions, meaning the x is up in exponent land. You had a facts table, a powers table, and if not, you could ask for one or pull one up. And your goal, and I wrote one that's not the exact problems in between there, you could see the one I wrote in purple. The goal here was to express both sides with the same base. So the example I have in the middle already has a base of 2 on one side, so I'm going to keep the base of 2 on that side. Then I would go to an exponents table, or I'd use my calculator to estimate what power of 2 128 is. And you could guess or check, or you could actually check with a powers table, and 2 to the 7th happens to be worth 128. So I have to get the bases the same first. That would be your goal in both 23 and 24. Once the bases are the same, then I can go ahead and drop the bases and say that the only part that then has to become equal is those exponents and solve from there. Okay, and that's a nice linear equation we could solve to get that x is 3. So in 23 and 24, make sure you're showing those steps that show you getting the base the same first on both sides and then making the equation out of the exponents.